I got all this on YouTube, by the way. Note, watch for the patterns. Those of you who are especially musically inclined.
Here's a quick and simple visual of Fibonacci sequence. Our visual will show up to the number 13 in the Fibonacci sequence. So we're going to place the blocks in such a way that represents the Fibonacci sequence. We start with our 1-inch block. It's 1 inch on all sides.
Color's not so great, sorry.
And then the next number in the sequence is 1, or another 1-inch block. The next number in the sequence is 2. Goes down. So we have our 3 blocks. So notice how when we're placing the next block down, it's completing the sides of the other block. Our 8 block goes here. And then our big whopping 13 on all 4 sides goes right here. So what's interesting about the arrangement of the blocks is how I said that we're always completing the sides when you add a new block on. And that's no surprise because in the Fibonacci sequence, the pattern is that, well, we start with 1, and then from there on out, you add the 2 previous numbers to get the next number. So in ours, we start with 1, then we add the 2 previous sides or numbers. So 0 plus 1 is 1. Then we add the next 2 sides. 1 plus 1 is 2. Then 2 plus 1 is 3. And 3 plus 2 is 5. 3 plus 5 is 8. And then 5 plus 8 is 13. If we were going to add another block, it would be 21 block because that's the next in the sequence. But also it would be the sides of our last 2 placed boxes, 13 and 8 combined.
Make sense?
To me, the most interesting aspect of this visual Fibonacci sequence is that when we draw quarter circles on the blocks connecting opposite sides of the squares, an image emerges that helps us connect the Fibonacci sequence to real-life phenomenons, and I will show that next. So as you can see, when we connect the quarter circles of the blocks, we get an obvious spiral pattern. So what's really neat about this spiral is that we find it in nature, most notably on a nautilus shell or on ram's horns. And when studying these spirals, we find out that they contain Fibonacci ratios. A Fibonacci ratio is when we have one Fibonacci number over another, so like 8 over 5. And that has been a quick visual on the Fibonacci sequence.
Sequence begins with the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, and continues indefinitely. Each number is obtained by adding the last two digits together. If we were to take a perfect or golden rectangle, break it down into smaller squares based on Fibonacci's sequence, and divide each with an arc, the patterns begin to take shape. We begin to see Fibonacci's spiral. The spiral in and of itself is insignificant. Its importance is revealed in where we find it. Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21, the sequence of Fibonacci. The fruitlets of the pineapple create the same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design that the tiny shell is formed.
The Fibonacci sequence is a sequence of numbers. Each number is the sum of the previous two numbers. The sequence starts with 0, 1, 1, 2, 3, 5, 8, 13, and so on. As the sequence continues, the numbers get larger. So basically, the 15th number will be in the hundreds. A visual two-dimensional representation of this ratio would look like this. This ratio is called the golden mean, golden section, and it's also known as the 3:5 ratio. You can see the 3:5 ratio in everyday life. It is in nature, art, architecture, and is reflected in the human body. The 3:5 ratio was known by the Greeks. It was believed to be the most beautiful ratio. Another visual of the golden ratio. This time, the rectangles are turned to its side in a shape which is called the golden spiral. The golden spiral can be seen in various places in life and in life itself. Some of the world's famous artists use this method in their paintings, artists such as Leonardo da Vinci. Many 20th century architects used the golden ratio in the construction of their structures. You will see the golden spiral in any shells. In the arms of spiral galaxies, you can notice the golden ratio take place. The golden spiral can also be seen in the formation of hurricanes. There is an important number relating to the Fibonacci sequence called 5. Any number in the sequence of numbers multiplied by 5 results in the next number. The number 5 looks like this: 1.6180339887, and the number keeps going on. To make things more simple, I'll be shortening the number to 1.618. For example, if you multiply 13 by 1.618, you will get the next number in the sequence. Each number in the sequence is roughly 1.618 times bigger than the last number.
Oh, did that make sense?
Yeah.
Kind of crazy. I don't know. I saw it and I thought that was pretty cool. So what I want you guys to do is, like, if you could fashion yourself in some kind of a formation of a circle, you get your phones out. If you have your phone on you, use a calculator. But we are going to become the Fibonacci.
No.
Who wants? Oh. Yeah. No, actually, it's pretty cool. We did this a few years ago when Jake, we were in the first year, right? Didn't we? Yeah, we did this in, so what I want you to keep in mind though, if you get hung up on like where you're at, what position you're at in the Fibonacci sequence, because eventually you're going to do a program, if you haven't already, that you'll do the Fibonacci sequence. In other words, you'll choose number 26, and that would be the 26th number in the Fibonacci sequence, which would be a very large number, right? So you're going to calculate it in your program. So if for some reason you lose track of, because it's easy to do, like we're going to start off, if you lose track at what position you're at or whatever, what number you should be adding plus what, or the numbers get really large, you can multiply your position by 5. Remember? And that's the golden ratio. Okay? 1 plus 0 is 1. Okay? 1 plus 1 is 2. So you're adding the previous numbers.
Oh.
Right? So we have, let's put it on the board, right? What did we do? We did 0 plus 1 is 1. Right? Plus, what's next? 1 is 2. So what are we going to do then? Here, what are we doing? 2 plus 1 is 3. Okay, so what's the next one? 5. What's next? 8. What's next? Good. What's next?
21.
What's next? 34? What's next? All right. What's next?
89.
Let's start over here. 89. What's next? 144. Okay. Mark, what's next? What is it?
233.
233. All right, who's game? Who's next? Come on, Outlanders here. Yes. Aaron.
Wait, what are the numbers?
144, 233. 377? You did that in your head? See, I'm already, like, you get into triple digits. Okay, 377. Good job. I know. Hey, I've always said, oh, I hate math, but, you know, then I started seeing the spiral. It's always been my favorite shape. I'm like, I guess ironically, I do like math. I do. Right? Okay. 233 and 377.
610.
610. What's next? Who's up next?
980. Wait,
Who said that?
987.
So who said 587?
987.
987? All right, good job, Adrian. All right, what's next? I'm taking you at your word. This is high-level math.
1537.
All right, so you guys, you got it? You see how it keeps growing and growing, and it's actually like an infinite number, right? It keeps just exponentially growing. So that is what Fibonacci is. And if you take that and you consider all the various means and everything that we saw, like whether it was in music or in nature or in architecture or whatever, you guys can see that it's everywhere, right? So what I want you to do is you're going to email me again, like you emailed me a few days ago with your reflections. I want you to email me again. I put my email back up here. I want you to email me with just kind of, you know, it doesn't have to be anything super lengthy or anything, but I want you to give me some examples of, like, I want you to tell me what stood out most to you as far as, like, you know, whatever we worked with today, like what you saw, whether it was like, oh, I totally got the music and I thought that was really cool. Or you could say, you know, the architecture, I thought that was cool. Then I want you to give me an example of, like, in your own life where you might see the Fibonacci sequence, okay? So real simple, but I want you to give that to me by, like, by the end of the block? Or at least by tomorrow morning. How's that? Okay? All right. Cool beans. Thank you.